Hey guys, welcome back to another DeltaMath tutorial. Today we're going to be talking about basic exponent rules, specifically looking at problems like this one. Now, this is what we actually call the power rule in exponent rules, talking about when we have exponents to other exponents, or a power to a power. Now, I love the phrase an exponent to an exponent. It just works better in my mind, I guess. But that's what we're going to be kind of trying to figure out. In this problem, it says 5 to the third to the fourth power. This is kind of weird. We don't usually see things like this in math, but we do still want to know what happens in this situation. What do we do? Well, you've probably watched the other videos in this series about exponent rules for multiplication and for division. And in those, you realize that even though we're multiplying the numbers, we actually add the exponents. Or if we're dividing the numbers, we subtract the exponents. We never quite do the same thing as what's in the problem. That's why exponent rules are kind of weird sometimes and can be a little hard to remember. So what do you think we do here? Well, I bet you already have a good guess, and you're probably right, but let's talk about the actual math behind it, why we do what we do. So we have 5 to the third to the fourth. So this is realistically kind of like saying 5 to the third times itself 4 times, right? Because 5 to the fourth would be 5 times 5 times 5 times 5. But 5 to the third to the fourth would be 5 to the third times 5 to the third times 5 to the third times 5 to the third. So we have a lot of 5s multiplying. How many though? Well, if there's 3 5s here, that brings it up to 6 5s with the next one, 9 5s after that, and then 12 5s. So do you think this is actually the same thing as 5 to the 12th? Well, if you thought that, you would be right, because it is. Now, there has to be an easier way to figure this out, though, than writing this out every time, counting up 3, 6, 9, that kind of thing, or whatever number it is you're working with. So how do you think we could get 12 as our exponent just by looking at this problem? Is there some sort of pattern we could follow? Well, I bet you guys are already noticing it. What are our two exponents there? 3 and 4, right? Now, what do 3 and 4 make when they multiply? 12. That's not a coincidence. That's how it will always work on these problems. That's why what I like to think of, what I envision in my head whenever I'm solving a problem like this, is writing the base number, the number we kind of start with, the 5, and instead of writing it to the third to the fourth, I like to write it as 3 times 4. I do that little bit of multiplication, and it gets me to my answer, 5 to the 12th power. So all we ever have to do on these problems is multiply the two exponents, or the two powers, and that will get us the exponent that is in our fully simplified answer. Let's go ahead and type in 12 as our answer. Make sure we got it right. Got to check our work like we always do. And yeah, we'll see if it worked. All right, while I am typing this in, please do like the video, subscribe to the channel if you have not already. That really does help me out a lot. And we're going to submit here. Let's see. Hey, we got it right. Okay. And, you know, if we look at the process they used for this, they kind of did the same thing as us, right? They broke it up into that 5 to the third times itself 4 times. They even just took it one step further to say 5 to the third is 5 times 5 times 5. And then they counted those out one by one. But we do want to recognize that kind of shortcut that we're able to take by just multiplying the exponents too. All right, guys, if you have any questions about what we went over in the video today, please leave them down in the comments below. I'll be happy to help out with those. And thanks for watching the video. I'll see you in some more DeltaMath tutorials.